In this video, I would like to overview the parallel lines with transversals and properties. So what we're going to do is to construct a line here in Geogebra, choose a point not on the line, and then construct a parallel line to that using the More feature, parallel line, select the point and line, and now we have a pair of parallel lines. Let's draw the transversal in any fashion. I'm going to draw it like this. Remember that once you've drawn it, if you click move, as long as you haven't locked any of the points in, this is dynamic, so you can change the picture and still see how the relationships occur. So you can notice that there are only, well, there's a total of 8 angles, but there's only 2 different measures. And one way you can play with that with Geogebra here is to measure all of these angles. It might be useful, and I would suggest clicking More once again. It might be useful to find the intersection points here so that you can more easily determine the angles and make sure that every sort of arm that comes off of that point has a point, so you can click on it when you're measuring the angle. And you'll figure that out yourself as you do it. So when we choose an angle, we could click like E, F, A, all right, and it gives us the measure of the angle as 59.1 degrees. Now, pause the video for a second and see if you can determine which other angles will also be 59.1. Okay, now that you're back, hopefully you paused it. If we click on BFG, which is big friendly giant, but BFG here would be also a 59.1 because it is a vertical angle. Now, the transversal hits the parallel line below. So notice that the corresponding angle there to the previous one, HGD, is also 59.1. And likewise, CGF is 59.1. So we have those 4 measures that are the same. And you can say that they're the same for a variety of reasons. So, for example, you have vertical angles, you have corresponding angles. That means angles that are in the same location, like bottom right or top left. You can also say the angles that are inside the parallel lines are alternate interior angles, are congruent because of the parallelism, and the ones that are outside the parallel lines are exterior alternate exterior angles for the same reason. Those are all fun to explore. Now, maybe pause the video once again and determine what would be the measure of the other angles that we haven't yet looked at. Okay, now that you're back, maybe you thought about how these are linear pairs and would add up to 180 degrees. I'm hopeful that you thought about that. And you can see that that measure would be 120.9 because 120.9 plus 59.1 would equal 180 degrees. Now, you could ask a GeoGebra to measure the rest of the angles. I'm going to leave it like that for a second. Going back to my move feature, no matter where I move this transversal, so if I move it over here, those relationships are still maintained. In other words, those 4 angles that are congruent are still congruent, and the 2 angles that are linear pairs still add up to 180 degrees. It doesn't matter how the transversal is sloped, it's always going to maintain that truth.